We're going to talk about a problem that's actually a really good sign. It's the problem of success. When your app gets popular, it almost always gets slow. So today, we're going to demystify one of the most powerful solutions to that very growing pain, database sharding.
Have you ever been using an app you absolutely love and then, over time it just starts to feel sluggish? Yeah, you tap something and there's that little pause. You try to search and that spinning wheel feels like it's going to go on forever. Well, it's not just you. It is a super common issue.
And the culprit is often a single, completely overworked database. I want you to imagine an entire massive city being served by just one giant library. I mean, as the city grows, what happens? The lines get longer, the librarians are totally overwhelmed, and just finding a single book becomes this slow, frustrating ordeal. That library? That's your database. And that growing city? That's your user base.
So how do you fix this overwhelmed library problem? You don't just build a bigger single library. No, you build more libraries. And that right there brings us to the solution in the world of data, sharding.
So what is sharding? It's simply the process of breaking up that one massive database into smaller, way more efficient pieces called shards. Going back to our analogy, instead of that one central library, we're opening up several smaller branch libraries all across the city. Each one is faster, it's less crowded, and it's a heck of a lot easier to manage. By dividing the work like this, the entire system can handle so much more traffic and stay snappy for every single user.
Okay, but just deciding to open new libraries, well, that isn't enough. You have to decide how you're going to organize them, right? Who gets which books? In database sharding, there are 3 main strategies for splitting up all that data, and choosing the right one, well, that involves some really fascinating trade-offs.
All right, let's dive into our first strategy. It's the most straightforward one, and it's called range-based sharding. As the name kind of suggests, it is all about organization. So with this strategy, you divide your data based on a continuous range of values. For instance, all your users with IDs from 1 up to 1 million, they go on the first server. The next million go to the second server, and so on. In our library analogy, this is like having one branch that only holds books published in the 1990s, another one just for the 80s, and a third just for the 70s. Super organized.
And here's where we hit that trade-off. On the plus side, this is incredibly efficient if you need to find stuff in a specific range. Think about an e-commerce site trying to look up all the orders from last month. You know exactly which server, which library branch to go to. Easy. But the con? You can create what are called hotspots. If all of a sudden books from the 90s become way more popular, that one branch gets totally swamped with traffic while the 1950s branch is sitting there totally empty. That one server is doing all the work and things slow down again.
So yeah, those hotspots can be a real pain. Our second method, which is called hash-based sharding, is designed specifically to solve that problem by creating a perfect balance.
Now, instead of using a simple range, this method takes a key, like a user ID, and it runs it through a special math formula called a hash function. The result of that formula then dictates which server the data goes to. Think of this like a central sorting machine at the post office. It takes every single book, runs a quick calculation on it, and sends it to a very specific branch. The result might look random, but it's actually designed to spread all the books out perfectly evenly across all the libraries.
The huge advantage here is a beautifully even distribution. No single library branch gets overwhelmed, so you completely avoid those hotspots. But what's the hidden cost of this perfect balance? Well, what if you want to find all the books written by a single author? Because they were sent out based on that hash formula, their books are now scattered across every single library branch in the city. Trying to find them all means you have to go to every server, and that becomes a very slow process.
All right, our final strategy is maybe the most intuitive one, especially when you think about global applications that have to serve users all over the world. It's called geographic sharding.
The logic here is just plain simple. Keep the data close to the people who actually use it. If a user is in France, their data lives on a server in Europe. If they're in Japan, their data is on a server in Asia. Our library analogy here is perfect. You'd open a branch in Paris and fill it with books on French history, right there for the local readers. It's all about reducing the travel time, or in the tech world, what we call latency.
The pro here is pretty obvious. It's blazing fast for local users. Those Parisian readers get their French history books in an instant. But the con comes up when users from different regions need to interact with each other. Think about a social media app. What happens when a user in Tokyo wants to check out the profile of a user in Paris? They can do it, but there's going to be a noticeable delay as that request has to travel all the way across the globe.
All right, so we've met our three main strategies. Now it's time for the main event. Let's put them head to head and see how they stack up in a direct comparison.
And remember, there is no single best strategy here. It is all about the trade-offs. It's about what's best for your specific situation. So let's see them side by side.
Okay, just look at this breakdown. Range-based, it's fantastic for those range queries, but you risk that uneven data distribution, those hotspots. Then you've got hash-based, which gives you that perfect, even distribution, but it makes those same range queries really inefficient. And finally, geographic is the absolute champion for global users, but that focus on location comes at the expense of the other factors. You can see how each strategy clearly excels in one area while making a compromise somewhere else.
So based on that comparison, how in the world do you choose? Let's break it down into a simple, practical guide. It really just comes down to asking these simple questions. Are you working with data that's based on time, like sales from last quarter or logs from the last hour? Range-based is going to be your best friend. Is your absolute #1 top priority to avoid overwhelming any single server? Then you'll want to go with hash-based. And are you building a worldwide service where speed for every single user, no matter where they are, is critical? Well, then geographic is the way to go.
And that really brings us to the end. We've gone from a single, totally overwhelmed library to this whole network of specialized branches, each with a very clear purpose. So the question for you isn't if your data will grow, it's how you're going to divide it when it does. Thanks for joining me.